Now we are going to another result. That is, the theorem states that if n greater than or equals 1, lambda n equals man-dot function lambda n. We know that lambda n equals, when n greater than or equals 1, lambda n equals sigma d divides n lambda d, that is nothing but log e. Okay. So if n greater than or equals 1, lambda n equals sigma d divides n or minus sigma d divides n mu d into log d. Mu of d into log d. This is the next result. If n greater than or equals 1, then lambda n equals minus sigma over d divides n mu of d log d. Or it is again can be expressed as sigma d divides n. It is mu d into log n by d. Log n by d. Mu of d into log n by d. This is the another result. So this result is reduced from here. Okay. How to approach this one? The proof is, what is log n? We know that by the previous result, when n greater than or equals 1, log n equals sigma d divides n lambda d. This is already proved. Okay. What is the Mobius inversion formula? Mobius inversion formula states that if f of d, if f of n, Mobius inversion formula states that if f of n equals sigma over d divides n g of d, then that implies g of n equals sigma over d divides n f of d into mu of n by d. This is Mobius inversion formula. Okay. If f of d equals sigma d divides n g of, if f of n equals d sigma over d divides n g of d, that implies g of n equals sigma over d divides n f of d into mu of n by d. Using that argument, in the light of that argument, instead of f of n, here it is log e. Okay. Sigma d divides n g of d, instead of g of d, here it is lambda d. So by using that Mobius inversion formula, what do you get? Here we know, here instead of g, here it is lambda. So g of lambda n equals sigma over d divides n. It is log d into mu of n by d. Okay, this is by Mobius inversion formula. Instead of f of n, here it is log e. Instead of g of d, here it is lambda. So if f of n equals sigma over d divides n g of d, then by Mobius inversion formula, g of n equals sigma over d divides n f of d into mu of n by d. So from here, we can immediately conclude that when log n is sigma over d divides n lambda d, then by Mobius inversion formula, lambda n equals sigma over d divides n log d mu of n by d. That means this lambda equals, or lambda n equals log star mu. Okay, where star be this is by Dirichlet convolution. Okay, f star g of n equals sigma over d divides n f of d into g of n by d. Why? Because that means here this means g equals f star mu. This is Mobius inversion formula. When f of n equals sigma d divides n g of d, then g equals f star mu. This can be again rewritten as f equals g of d into u of n by d. Means if f equals g star u of n is 1, u of n by d is again 1. Why? Because d runs over all n over through n by d. So when f is g star u, then g is f star mu. That is Mobius inversion formula. Here lambda n equals sigma d divides n lambda d. Sorry, log n equals sigma d divides n lambda d. Then lambda equals log star mu. But we know that the convolution is the Dirichlet convolution or the Dirichlet product is commutative. So log star mu is nothing but mu star log n. Okay, mu star log. That means what is lambda n? Lambda n equals mu star log n of n. So mu star log n of n. That equals sigma over d divides n. It is mu of d into log n by d. Mu d into log n by d. That is what we require here. That's our first requirement. For n greater than or equals 1, lambda n equals sigma over d divides n, mu of d into log n by d. Okay. Then that means here we can use the property of logarithm. That equals sigma over d, mu of n equals sigma over d divides n, mu of d into, it is log n by d. Log a by b means log a minus log b. So it is log n minus log d. That equals, it can be rearranged as, it is log n into sigma over d divides n, mu of d, okay, minus sigma over d divides n, mu of d into log d. Clear? We can distribute this mu of d. Open this bracket. That is sigma over d divides n, mu of d into log n. That is log n into sigma over d divides n, mu of d, minus sigma over d divides n, mu of d into log d. But we know that what is sigma over d divides n, mu of d? This is a familiar result, or this is a proved result. Sigma over d divides n, mu of d equals, it is greatest integer part 1 by n. Okay, or it is nothing but I of n. That's a proved result. So this is log n into I of n, or minus sigma d divides n, mu of d into log d. Okay. So listen, when n equals 1, what happens here? When n equals 1, log 1 is 0. Sure? When n equals 1, log 1 equals 0. When n greater than 1, I of n equals 0. Why? Because I of n is integer, greatest integer 1 by n. When n greater than 1, greatest integer 1 by n should be 0. So when n equals 1, log n equals 0. When n greater than 1, I of n equals 0. So for n greater than or equals 1, the first term always goes to 0. What remains there? So for n greater than or equals 1, lambda n equals minus sigma d divides n, mu of d into log. Okay, so that is our requirement. Clear? Yes. So this is the man dot function. So man dot function is defined as when n equals power of a prime p, then lambda n equals log p equals 0 otherwise. Also we know that for n greater than or equals 1, log n equals sigma over d divides n, lambda d, or it is sigma over d divides n, mu of d into log n by d, or it is sigma minus sigma over d divides n, mu of d into log d. Okay. So, and that result heavily depends upon Mobius inversion formula. So, just to come to the behavior of Mobius inversion formula, Mobius inversion formula says that if f of n equals sigma over d divides n g of d, then g of n equals sigma over d divides n f of d into mu of n by d. That means this g of d, sigma over d divides n g of d can be rewritten as g of d into u of n by d. Why? Because we are define this result. What is u of n? U of n equals 1 for all n. So u of n by d is also 1. That means if the Mobius inversion formula is restated as in this way, if f equals g star u, then g equals f star u. So this is actually Mobius inversion formula. This is the another statement of Mobius inversion formula. If f is g star u, then g is f star mu. Agree? Okay. Now, Now consider another result or another definition. Suppose f is an arithmetic function, means the function or it's defined over positive integers. F is an arithmetic function, and for any two positive integers m and n, any two positive integers m and n, suppose they are not relatively prime, then, and also if f is not identically 0, if f is not identically 0, then if f of mn equals f of m into f of n for all m and n, for all m and n, then the function f is said to be completely multiplicative. A function, an arithmetic function, f is said to be completely multiplicative if for any two positive integers m and n, having for any two positive integers m and n, then f of mn equals f of m into f of n. If f is not identically 0, then f is said to be a completely multiplicative function. Suppose if it happens in this way, if m and n are any two positive integers with f of mn equals f of m into f of n, if m and n are relatively prime, if this hold only for these m and n's, if m and n are only relatively primes, if m and n are relatively prime and f of mn equals f of m into f of n, then f is a multiplicative function. This is the multiplicity of a function, arithmetic function f. This is its complete multiplicity. A function f is said to be multiplicative. Arithmetic function f is said to be multiplicative if f of mn equals f of m into f of n when m and n are relatively prime. It is said to be completely multiplicative f of mn equals f of m into f of n. That is true for every m and n. Okay, so this is the definition of a multiplicative and completely multiplicative functions.